For as long as people have been around, we have been wondering how it all began, and moreover, who started it all. Everything in the universe, of course, depends on the universe for its existence, among other things. But what about the universe itself? If you define the universe as everything, then it is impossible for anything to be outside it. But another way to describe the universe is a region that is separated from another by a topological boundary like a horizon, a boundary that stops information crossing from one region to another in at least one direction. You can say you have multiple universes even though they are connected to one another. If you have multiple universes like this, you have a multiverse. If this universe is contingent, then we must ask how it came to be. What is it contingent on? One recent philosophical thought experiment is that the universe is a simulation, and that it is, in fact, contingent on some advanced computers sitting in a real universe somewhere. As a thought experiment, the simulation hypothesis is powerful, but as an ontological statement about reality, it is very weak. The argument, due to Nick Bostrom, makes use of some dubious probabilistic assumptions to arrive at its conclusions, and there is absolutely no evidence for it. An alternative is that intelligent beings may have created the universe the old-fashioned way, by creating a false vacuum in their own universe, which then allowed ours to form. Unlike a digital simulation, this universe would be indistinguishable from a real universe because it is one. Scientists, notably the well-known cosmologist and proponent of inflationary theory Alan Guth, have looked at the possibility of creating our own mini-universe in the lab via quantum tunneling. If such a thing is physically possible, then it is entirely reasonable to suggest that our universe was created in an alien lab. On the face of it, as the authors of a 1990 paper admit, it seems absurd to try to create a universe inside another one. The universe we inhabit has about 10 to the power 32 solar masses of material. How could anyone get all that mass together to create a new universe? The answer is inflationary cosmology, which gives us a way to create universes from only about 10 kilograms of material. While 10 kilograms is not a lot of material, the density requirement is substantial at about 10 to the power 76 grams per cubic centimeter. By comparison, the densest matter ever created on Earth, a quark-gluon plasma made by smashing lead nuclei into one another in the Large Hadron Collider, is only about 4 times 10 to the power 16 grams per cubic centimeter. Nevertheless, imagine an advanced race has learned how to produce such densities. A new universe can be created out of a spherically symmetric bubble of false vacuum. This is a state where its vacuum has an energy higher than the true vacuum. In other words, energy permeates the bubble such that the lowest possible energy is higher than the great nothing of true vacuum. This bubble will experience inflation for a time and then settle into the same kind of expansion that our own universe experiences. The bubble is separated from the true vacuum by a thin layer. Inside the bubble is a de Sitter space, a space that is thought to resemble our own universe with positive curvature even in the absence of matter or energy. On the other side of the layer is a true vacuum with what is called a Schwarzschild geometry, the geometry that resembles that of a black hole but also that of any spherically symmetric body like the Earth or Sun. In our case, the Schwarzschild geometry has a mass that is equivalent to the energy of the bubble, according to Einstein's famous relation, E equals mc squared. Once our alien scientists get their new universe started and expanding, you might ask if the new universe explodes into theirs, destroying them and anything else in its path, like some mad science experiment gone wrong. This is not so, however, thanks to the Riemannian geometry of Einstein's general relativity. The universe would exist behind the event horizon of the Schwarzschild geometry, effectively shielded from them, as if it were inside a black hole. Our universe would expand without any contact with theirs. It is because the math is very similar, except that there is in this formulation no actual singularity, only an extremely dense region of matter with an event horizon around it. The authors of the paper determined that a lab-created universe must avoid any singularity. They run into trouble, however, using only classical general relativity. They cannot create the necessary false vacuum bubble without a singularity. This is a consequence of the Penrose theorem. Thanks to this theorem, Penrose was awarded the Nobel Prize in 2020 for his contribution to the theory that black holes and their singularities are robust predictions of general relativity. The problem comes down to mass bounds. Below a certain mass, a baby universe will expand briefly and collapse in on itself. Above that, baby universe will expand, then collapse, and then expand again and continue expanding like our universe. Then above that, the baby universe will expand continuously. The problem is that to avoid a singularity, the baby universe has to have a mass that is so small that it would just collapse in on itself. End of story. All these are predictions of classical general relativity, which means there is no avoiding them. This means we have to turn to quantum theory. A phenomenon called quantum tunneling allows for certain violations of classical physics, including general relativity using principles of uncertainty, which enable, for example, particles to travel through impassable barriers. Quantum tunneling does not only apply to physical barriers like walls, it also applies to any kind of trajectory. For example, a particle in a stable orbit around the Sun could, through no external influence, tunnel into an unstable trajectory, escaping the star. In classical physics, there is effectively a wall between escape velocity and orbital velocity, but a particle can tunnel through that barrier. This principle applies not only to the trajectories of particles, but entire universes. A universe with a mass that should lead to immediate collapse into nothing, therefore, can theoretically tunnel to a trajectory where it bounces and expands again without any additional mass or energy that might lead to a singularity. Quantum theory is only required to explain the tunneling aspect, after which classical physics takes over, meaning that our universe, should it have been created as an inflationary false vacuum bubble in an alien particle accelerator or equivalent, would not bear any hints that it resulted from quantum effects. Another result of inflationary theory is that the small initial mass of the baby universe would expand enormously effectively, converting nothing into matter and energy by the expansion faster than light of false vacuum. Since false vacuum states are metastable, one theory is that the false vacuum decays into true vacuum by bubble nucleation, where quantum effects restore the vacuum. By analogy, if you place a smooth mug full of water in the microwave and heat it to above boiling, it may remain liquid without any bubbles to indicate it is above boiling. This is a metastable state that results from the smoothness of its environment, preventing the nucleation of bubbles. A tea bag or even a puff of air disturbs it. It suddenly springs to life with bubbles and the water boils, returning to a stable state. Likewise, with the universe, it may have formed a false vacuum which inflated, causing all the matter and energy we see to be created from nothing. Then quantum effects, acting like the tea bag, caused bubbles of true vacuum to appear, halting inflation and restoring thermodynamics. Unlike my earlier articles on this idea happening naturally, in this case no singularity is needed. There is no black hole. Rather, there is simply a very dense region of mass which initiates a quantum tunneling effect to create our universe. To our alien creators, it is not clear if they would know whether they had successfully created a universe or not. They would likely have to make a very large number of bubbles in order for one to tunnel into a true universe, because the probability is incredibly small. These tiny bubbles, smaller than a subatomic particle, would expand and follow their typical classical trajectories. You can imagine trying to escape the solar system by shooting a huge number of tiny spacecraft into orbit, hoping that one tunnels into an escape trajectory. As with a black hole, the observers would not really see anything going on inside, since anything at the horizon of the bubble would be frozen in time. A few bubbles, however, will reach their maximum radius and tunnel to a larger radius inside the horizon. To the outside observers, they would see the bubble vanish at the point of tunneling. The bubble would still be there, but would be completely cut off from its parent universe. Although the tunneling event implies vanishing, the converse isn't necessarily true. If the bubble did vanish, it isn't clear if a new universe had been created or whether some other quantum effect was going on. Still, it would be clear that something different from the classical had happened. Even if aliens created the universe, which this theory only suggests may be possible, those aliens are likely contingent on the universe they themselves inhabit. So it doesn't answer the cosmological argument. Who started it all? It depends on whom you ask. And perhaps such a question necessarily goes beyond concepts like universes, matter and energy, or even mathematics to some undefinable and ineffable realm where cause and effect, being and non-being cease to have meaning. Thank you so much for joining us today. See you soon in the next video.